The calculator provided by UTME might be the reason why many students will not be able to do well in their exam, both science and commercial students. And as somebody who wrote the exam in 2025 and I did very well, you can see my results here. I got 349. This is my results. I have 98 in mathematics and I have 98 in physics, 85 in chemistry. You can see that. I'm about to teach you all the necessary math skills that you need to know to excel and do very well in all these subjects. So these math skills cut across both economics, physics, chemistry, and all of that. And the first one we're going to be testing with in these 3 videos, so there are going to be 3 parts. You can check the playlist for the 3 of those videos. The first one is fraction, decimals, and percentages. This is very, very important if you are going to excel in your UTME. And the way it goes is that I'm going to show you how to convert from fraction to decimal and then how to divide by denominator and all of those things. Everything is going to be covered in the entire playlist. First, we need to understand the type of fractions that we have. We have 3 major types of fraction. We have the proper fraction, which is such that a proper fraction a over b, the way they work is that the numerator a is less than denominator b, and at the end of the day, this a over b is going to be less than 1 in value. That is for proper fraction. For improper fraction, you have a over b. In this case, a is greater than b. That means that a over b is going to be greater than 1. And the last one, you have a mixed fraction. You have a whole number coupled with a proper fraction a over b, and this is the third type of fraction that we have. So let me give you an example of what a mixed fraction is. For instance, you have 3 whole number 1 over 2. This is a mixed fraction, and this actually means 3 plus 1 over 2. So to convert mixed fraction, we can convert mixed fraction to improper fraction. All we have to do is to multiply these 2 numbers first. 2 times 3, that will give us 6. Then we add it to the number at the top. That will give us 7. So you have 7 over 2. And how do you convert from improper fraction to mixed fraction? If you have 9 divided by 5, how many times will 5 go in 9? That's once. And the remainder is 4. And here you have 4 over 5. And this is going to be your result. So quickly, how do you convert fraction to decimal? Most of the time, you can easily press your calculator that is provided by JAMB for this. But there are some fractions that you should know offhand already. Like without anybody teaching you anything, without you pressing your calculator, some fractions are so easy and direct to get them. So I'm going to give you a list of some of those things and how you can easily get them in the exam hall as well. For instance, 1 over 2 is 0.5. You need to master that. Followed by 1 over 3 is 0.33. It is repeated like that. It continues to repeat. Then you have 1 over 4. 1 over 4 is 0.25. Then you have 1 over 5. That's 0.2. 1 over 6 start with a 0.1. Then you have 6 being repeated like that. So this is going to be approximately 0.17. And then you have 1 over 7. 1 over 7 is one that does not have a pattern. 1 over 8 has its pattern as well. Like that is around 0.125 for 1 over 8. And it goes on and on until you get to 1 over 10. 1 over 10 is going to be 0.1. And I've been giving you all of these different guys. You can get guys like 2 over 3. You can get guys like 3 over 4. You can get guys like 4 over 5. How do you do that? Since you already know 1 over 3, then 2 over 3 is just 2 times 1 over 3. All you have to do is to multiply the value of 1 over 3 that I already gave you here by 2. You already know 1 over 5 is 0.2. How then do you do 4 over 5? Just multiply 4 over 5 with 4 with 1 over 5. That will be times 4. And you have what? 0.8. So you can manipulate your way around any fraction and convert them to decimal in this place once you know the basic ones I've given you like this. And next is to convert to decimal. To convert decimal to percentage, rather, all you have to do is just multiply that result by 100. For instance, look at this example here. Express 0.375 as a percentage. Just multiply by 100 and you have 37.5%. Very easy and very straightforward to deal with. And how do you find percentage? Percentage, you can have a percentage which is actual value over theoretical. So in this case, I want to teach you percentage change. Percentage change is simply the change over the original value multiplied by 100. And when I say original value, many people usually mistake it. For instance, let's say there's a change from 30 to 50, and you want to find the percentage change. The change itself is 50 minus 30, which is what? 20. How do you now do the percentage? That would be 20 divided by 10, 30 times 100. Then you do this simplification. Like now, 2 over 3, that would be 0.6. So this is 2 over 3. That would be 0.66666666. And then when you multiply by 100, you have 66.67%. You can see that I did not use my calculator at all to do this. That is exactly one of the things I'm trying to teach you here. Now, this is percentage increase. But let's say you have something that moves from, let's say, from 70 to, let's say, 40 in this case now. This is going to be a percentage decrease. And that will be 70 minus 40, which is what? 30. So you're going to have 30 over 70. So you can see in the first case, I divided by 30. In this case, I divided by 70. You will always have to divide by the original value to get percentage increase or percentage decrease. In this case, you want to find 35% of 240. You don't need to start writing 35 over 100. Just count backward 1, 2, and put a decimal point. That will be 0.35 times 240. And easily, you get your answer within a snap of a finger. That's the first key thing that you need to know there. Don't forget, if you have any problem with anything I'm teaching you, you can always drop them in the comment section. I'm going to address any of your problem, and I might even make a video about it if there's need to. Now, next one is ratio and proportion. This one is very, very, very important. You need to be able to divide into ratio, and you need to know that ratios can be simplified. If you have ratio A to B, it basically means A over B. At least you can find this ratio simplification. However, you need to be very, very careful in using the actual ratio when you are solving problem. Another thing that most students usually make mistake with is that when they ask you to find the ratio of two things, let's say you have solved all the problem and you get to a point where you have, let's say, 3x equals 4y. And the question wants to find the ratio of x to y. So most people usually believe that, oh, the value that is with x, this 3 is for x, and this 4 is for y. That is not true. The converse is the true. So is the true case. So if you have x ratio y, that's actually going to be the number with y is what? Is 4. And the number with x is what? 3. So x ratio y, you will go and choose those coefficients of the other guy on the other side. And if you want to do it the normal mathematical way, the first thing you do is that you divide both sides by y. So you have 3x over y equals 4. The next, you divide both sides by what? By 3. So you have x over y equals 4 divided by 3. So you can either use the approach I taught you earlier, or you do the normal mathematical way. And take notes of this very well. Very important. So how do you share in ratio and to find total part? All you have to do is to find total ratio. So if I say 2 ratio 3 ratio 1, total ratio here is going to be 6. So if I want to get the part of the person that has one share ratio, that will be 1 over 6 times the total thing that I'm trying to share. So you can take some of the examples that we have here as well. So if you want to simplify this ratio here, 120 to 180, so this goes here. 6 can go in 12, that's 2 times. 6 can go in this, that's 3. And that will be what? 2 over 3 or 2 ratio 3, which in decimal is like 0.67. And so that is how you deal with ratio and all of that. Now, let's go to the next topic. We have powers, roots, and indices. Very, very, very important. You need to know all these basic rule of indices. All these basic rule. And you need to take note that since I said that a raised to power m multiplied by a raised to power n is a raised to power m plus n, it does not mean that a raised to power m plus a raised to power n is not going to be equal to a raised to power m times n or whatever it is that you're trying to do. This is not going to be true. Make sure you don't make such mistake in the exam hall. And you need to know your powers of 10, whether they are positive or whether they are negative. Can you see this now? Powers of 10 raised to power negative 3. 3 zeros are appearing here, where 1 is before the decimals. And then you have 2 raised to power minus 1 is 1 over 2. That is, whenever you raise a number to a negative 1, it's just the inverse of that number. Or the general format, which is what? A raised to power negative n equals what? Equals 1 over a raised to power n. Like in this case now, you have 3 raised to power 4 times 3 raised to power minus 2, you can either apply the indices rule, which says this will be 3 raised to power 4 plus negative 2, and this would be what? 3 raised to power 4 plus negative 2, that's 4 minus 2, and that will be 3 raised to power 2, which is 9. Or you can say this is 3 raised to power 4 multiplied by, if you apply this rule here, that will be 1 over 3 raised to power 2, and you can do your simplification from here. So that is how you undo this exponential rule. If you need further simplification and you want me to address it further, you should let me know in the comment section. By the way, there are other parts in this video where I explain some other exponential rule. Let's go to the next topic. We have the standard form, scientific notation. You need to be able to write anything, any number in scientific notation. And what is the purpose? The purpose is that we don't want to have too many zeros repeating and being cumbersome everywhere. We want to compact our result into a simplified form. And the rule is that there are two things that you need to pay attention to. The number one rule is that there must be only one number to the left of the decimal. Only one number to the left of the decimal. And this number cannot be 0. Those are the two rules that you need to pay attention to. One number to the left of the decimal, and this number cannot be 0. For instance, in this place now, this is a whole number, 45,000. That means that the decimal point is going to be just right after this. So you want to convert this one to standard form, or what we call scientific notation. What you do is that you shift this until there is only one number after the at the left of the decimal. So you have 1, 2, 3, 4. You've shifted that 4 times. And where did you move towards? Left hand side. Once you shift decimal to the left hand side, you get a positive power of 10. That is why in this case you have 4.5 now, because the decimal point is now here. 4.5 times 10 raised to power 4, which is the number of times you shifted your decimal point to the left. In this case, let's look at it. We have 1, 2, 3, 4. So you can see that if I shift this down, 3 will be the only number to the left of the decimal. That will be 3.2. And I shifted it also 4 times. That's 1, 2, 3, 4. And because I shifted it from what? From left to right in this case. From left to right. Then the power is going to be a negative power of 4. So let's quickly do this one here. Let's shift this. This will be 1, 2, 3, 4, 5, 6. I shifted this 6 times so that it can be that one number and the number is not 0 to the left of the decimal. So that would be 7.8. How many times did I shift that again? Let me count again. 1, 2, 3, 4, 5, 6. So that is going to be times 10 to the negative 6. Why? Because I shifted from left to right. And if you have 3.6 times 10 raised to power 5, since the power is a positive power, that means that this number is going to become bigger. All you have to do is what? Just shift it to the right. Positive power shift to the right. Negative power shift to the left. But when you shift decimal yourself to the left, you produce what? A positive power. And when you shift decimal yourself to the right, you produce a negative power. It sort of works like a converse related thing. Let's go to the next one. Significant figures and decimal places. You need to be able to find numbers in significant figures. And these are the rules that you need to follow. First of all, any non-zero number will always be significant. That is, as long as the number is not equal to 0, they will always be significant. Next is, let's now deal with 0. When do we have zeros that are significant? Zeros that are significant, this is the way they work. Number one, they cannot be at the end of numbers. These zeros, as in this case now, they are not significant. Now, which other zero do we have that is not significant? If they are coming before a number, they are also not what? Significant in this case. But when can we have them to? In fact, if you have 0.000032, these zeros are also not significant. However, when you begin to have zeros in between numbers, like you have 30004, these zeros are significant. So in this place, you have 1, 2, 3, 4, 5, 6. You have 6 significant figures in this place. In this place, even though you have 1, 2, 3, 4, 5, there are only 2 significant figures in this situation. So that's the number one place where zeros are significant. Now, let's look at another place where zeros are significant. If I have 32, 000, like I said already, this is not, the zeros here are not significant. But you see, the moment I put a decimal point either here, 33.000, these zeros become significant. In fact, the decimal point can be here, the zeros become significant. So what we mean is that when you introduce decimals, the zeros that are after become significant. Zeros that are after non-zero numbers become significant. But you can see in this case, even though there is decimal point, the zeros before any number they are not what? They are not significant. And these are the major things that you need to pay attention to know when zeros are significant and when they are not significant. So with this, you should be able to convert anything to significant figures. This one now to two significant figures, you know that these first three zeros are not significant. So I count 1, 2. That's what? 2 figures. Then you check the next number. The next number is up to 6. Sorry, more than 5. Then you can round it up to what? 1. So instead of 4, 5 now, this is going to be 4, 6. And you have 0.0046. Let me pick one example from this place. I'm going to use this one in particular because this one is actually very tricky. To convert this one to 3 significant figures, let me count. This first number is significant, second one, third one. But you notice that the next number is 6, which is greater than 5. Anything that is equal to 5 or greater, you just round it up to 1. But when you come around and you add the 1 to this place, what is it going to give you? A 10. And from there, you will only write 0. So let's see, you write 0. You keep 1. You add the 1 to the next line. That's also another 10. So you write 0, you keep 1. Then you add 1 to this place, so you have decimal point, and you have 1 plus 9, that's 10. But unfortunately, if you've been following what I've been teaching you so far, you know that this is not 3 significant figures. This is 4 significant figures based on the decimal point that is there. So what do? You write this to be 10.0. And this is when the result is correct. 2, 3 significant figures. And that's that. Until decimal place follows the same rule. But in that case, you don't have to worry about, oh, is 0 significant? Is it insignificant? It's just the number of decimal place that you have. So it's quite easily done. So this one, you just count the number 1, 2, and then you round it up. So let's go to the next topic. Substitution into formula. This is a very simple and basic skill, but many people still tend to fault at it. You should learn how to impute values properly into formulas. For instance, if you have v equals to u plus at and you want to find v, put everything appropriately. Use brackets to separate values. Don't mix everything up together. For instance, in this case, you want to find kinetic energy and you are given m, you are given v. That means that you have 1 over 2 multiplied by what's your m? 4. And what's your v? 10 raised to power 2. This power is being squared. So learn to do that. You can see how I put everything into brackets so that everything is properly done. And you can do this. That will be 2. 10 raised to power 2 is 100. And that will be what? 200 joules. Sometimes you are putting in a negative value. So for instance, in this place, let me solve this one. You want to look for v in this place. So v equals, what's your u? U is 20. Plus, what is a? A is -2. So you can see the way I just applied that here. And what is your time? Your time is 5. I'm using bracket to separate so that I won't mix things up together, especially in the case of this plus and minus place. So v will now be equal to 20 plus, I will now do -2 times 5. A negative number times positive number will give us a negative number. So that's -10. And v will now be 20 plus times minus is what? -10. And that will be 20. That will be 10. So you can see the way to learn to properly substitute. Don't be too in a hurry to substitute. And all of these things, I've done it so far without using a calculator. Now let's go to solving simple equations for one unknown. You need to learn to properly isolate. I gave an example here, but I'm going to use a much more complex one to explain to you. For instance, let's say you are solving this particular equation. You're solving for let's say 2xy plus 15 equals, let's say, 30. Now, this is very, very easy to do. What you have to do is that you get rid of the things that are far away first before you get rid of others. I want to make x here the subject of formula. I will need to get rid of 15 first because it's farther than y and 2. So I will say 2xy equals 30 minus 15. Then I will then say, now that I have x and y only, I will divide both sides by the two things, 2 and y, 2 and y. So you can see how I used my division sign to cover everything that is 30 minus 15, even though you can still evaluate what that is. So how do you get rid of positive? By subtracting. How do you get rid of negative? By what? Adding. How do you get rid of multiplication? By dividing. And how do you get rid of the division? By what? Multiplying. That's exactly what I just showed you here in this place. Let me do one more example, this time around something much more challenging. If you have, let's say, 2 over x plus 1 equals 4 over x minus 2. And in this case, you want to solve for x. In this place, this is where you cross multiply. So you cross multiply and you have 2 multiplied by x minus 2, as you can see that, equals 4 multiplied by x plus 1. You see, whenever you have problems like this, and multiplication is the one joining these two guys, you can easily divide. I can say 2 goes here 1 and 2 goes here 2. That helps me simplify this thing better. And so I will have x minus 2 on the left, and I can use this 2 to open the parentheses. That will be 2x plus 2 times 1, that is 2. Then I can do this, that will be x minus 2x equals 2. When negative 2 goes to the other side, that will become what? Plus 2. So x minus 2x is minus x, and then 2 plus 2 is 4. This implies that x is going to be equal to negative 4. So you should learn how to do cross multiplication properly. You need to practice this thing over and over and get used to them so that you don't get confused in the exam hall. Very, very important. And the next one is rearranging formulas, change of subject. I already introduced it to you there in that place. So you need to learn how to arrange properly a subject or formula. There's this particular concept that is always common. Imagine I give you s equals ut plus half at squared, and I ask you to make t the sort of formula in this place. It is not actually complex. What you have to do is that t is in the quadratic term here, so you have to solve it quadratically. So what you do first is that take everything to the right hand side. So you have what? Half at squared plus ut minus s equals 0. So I just brought this one to join them and rearrange it. So if you look at this now, this is a quadratic equation, and using that formula, t will be minus b plus or minus square root of b squared minus 4ac, everything divided by 2a. In this case, your a is actually 1 over 2a, your b is u, and your c is minus s. You just substitute into this formula and you solve your problem. That's exactly how you solve complex ones like that. And just like I've told you earlier, I've already explained how you make something the subject of formula. This is very important. If you have any complex subject of formula that you want me to address, just let me know in the comment. I'm going to be attending to it. And don't forget to subscribe as well if this video is helping you so far. And that is the only way you can have access to any other future videos that I'm going to be posting. Simultaneous equation, the basic one. I always recommend for students, substitution is the best way. Reason is because elimination can be simple, but when you are solving complex questions that have, let's say, powers involved, elimination will not work out. So always learn to substitute. For instance, you are solving a question, they say x squared minus y equals 15. And they say x plus y equals 2. And you want to solve for this in this situation, what you have to do is that do substitution. You cannot do elimination in this case. So, because even if you do your elimination, it's still going to lead to a quadratic. So substitution is always your best bet. In this case now, you can just say x equals 2 minus y by taking y to this side. Or you solve for y instead, y will be 2 minus x. So that implies that anywhere you see y, you can always replace it with 2 minus x in the first equation. And that's going to be x squared minus, so what is y now? Y is 2 minus x. If you observe, I did not just say x squared minus 2 minus x. This will be a disaster because the entire y is what? 2 minus x. So therefore, when I'm substituting inside, I have to put a parenthesis to make sure that the minus sign affects everything here. And this will be equal to 15. So if you continue, that will be x squared minus 2 plus x equals 15. And you have x squared plus x minus 2 minus 15. That's going to be negative 17 equals 0. Then you can solve this one using the quadratic formula that I've given you. Like I said as well, quadratic formula always work for any quadratic equation. Master how to use that very well. I will also create a video on how to properly use the quadratic formula in another video. Now, word problem, the last one I'm going to be taking for this part. Don't forget there's part 2 and there's part 3. Make sure you check them out. Now, word problem, you need to be able to know what it means that when you say more than means you add. When you say less than, it means you subtract. Times as much means you multiply. Shared equally means you divide. Take note of these terms. Once you know these terms, it's going to be easy for you. So to find the value, then you are setting, you set up and solve the equation. A number is 5 more than twice another. So a number, represent that with x. It is when you see is literally simplify that this is going to be equal to 5 more. Don't forget, 5 more means that I'm adding 5 than twice another. Twice another means that what? Let the other number be y. So twice that number. So you can see the way it works. And the x equals to 2y plus 5. You just have to break everything down into simple understanding and use the keywords that I've described here. And with that, you are going to be good to go. So for instance, if you have these, say a boy is 3 times as old as his sister. Together, they are 28 years old. Find the boy's age. A boy, let's start. A boy, let's say that boy is B, is equal to 3 times as old as his sister. That means that the boy is the one who is 3 times the sister. And then they also are together, that is the boy and the girl. They are both 28 years old. So here, what are you looking for? Find the boy's age. From this place, you can say that B equals 3s. Everything is already in the substituted state. So you just say, anywhere you see the boy's age, you put 3s. That means that 3s plus s is going to be 28. That means that 4s is going to be 28. And s is going to be what? 7 years. That implies that the boy's age will be 3 times 7, which is what? 21. You need to learn how to solve word problem. So just like I've promised, if you paste any word problem in the comments, I'm going to attend to them and I'm going to be making videos about them most likely. But you need to subscribe to my channel and like and comment and share this video. Share this video with all your friends that are also writing UTME. You're not the only one that wants to pass. By the way, this is the end of part 1. In part 2, I'll be talking about rates, graphs, geometry, and trigonometry. Don't miss it out. I'll be talking about that in part 2, and I'll see you in the next one.